Okay, good afternoon and welcome to Weather Watch. We're going to go through our map discussion. We'll talk a little bit about the forecast coming up, which is unfortunately some freezing rain. There's a possibility in the forecast. We'll look at that, maybe transitioning to snow, and then we'll look at our long, cold, damp winter will continue, it looks like, until April. But we'll focus on that a little bit later. This is the current visible satellite imagery.
It's 2 days old. It's 2 days old.
It's 2 days old. Thank you very
much. Yeah, I found that out this morning too.
We can just go to the IR.
Said something with the feed.
This is today's. I'll have to go look and see what you might be using a different thing.
It looks similar, but
you can see the feed is affecting the modeling. It should be.
Okay, so here's our visible satellite imagery, and thanks, John, for pointing out. Looks similar to what we were looking at earlier, but one of the key features that we saw last week and perhaps the week before is this sort of persistent easterly flow in the Caribbean and southwestern Caribbean that sort of curves up into the southeastern part of the United States. And this flow around a broad subtropical ridge that at times has been at a pretty good extent all the way into central Mexico, and it's been moving back and forth, but I think generally a persistent feature of the last couple of weeks has helped to fuel what we were anticipating about 2 or 3 weeks ago, heavy precipitation along the southeastern United States, along sort of a quasi-stationary baroclinic zone that's draped along the northern edge of that broad subtropical ridge. And we'll see some of the precipitation today that's there, but also the forecast coming up. So it's a really interesting feature. Again, we have this long fetch across the Caribbean and then northward into the Gulf of Mexico, as they are slowly getting moisture and becoming more moist. And we'll see the dew points along the southeastern part of the United States are now into the low to mid 70s in parts of Texas and Louisiana at this point. Further to the north of this cloud shield that extends from the tropics, well south of Mexico, into the southeast, into the central United States. Just a little bit of sun here. These aren't clouds. This is actually snow cover that we see. So our deep snow cover over us. Madison, last hour, reporting a snow depth of 4 inches. That seems a little bit smaller than what I would have anticipated, but it's slowly melting. Yeah, let's do that.
I don't understand the snow mass budget at the airport.
Right.
10 will fall, and then it's the next day there's 2 inches of snow on the ground. I don't understand.
There's some sifting and whatever, I guess.
Yeah, I guess so.
To look at this moving composite. Okay, you can see those clouds that went by. And there was also a curious feature that earlier this morning, which probably we have to look at the IR to see it. I think some of these clouds were actually producing a little bit of light snow just to our south. The radar showed it this morning, just south of us. And you can see snow cover over us. It's snow cover even in the northern part of the state, but you have a lot of coniferous trees, and so I guess the snow falls between the needles, and you're only seeing the tops of the trees as opposed to looking all the way to the ground, but less so to the south. So you can see that snow packets over us. And we can also, when we look at the temperatures, it will be interesting to see the differences between regions well south of Rockford and Chicago that are right now look like at bare ground to see what the impact of temperatures are there versus in the deeper snow cover to the north.
Is that a land breeze convergence line in the center of Lake Michigan too?
Oh, it looks like
that's a short parallel band. It's not very strong
right.
because the lake's partially frozen.
Okay, this is ice, right?
Yeah.
Ice, yeah. So is this really thin ice? That's just the edge of it, or what's?
Looks like it must be thin ice.
Yeah, it extends from the shore all the way into the initial waters of the lake. So
or it's been blown away from the shore out into the lake. I don't know. I haven't watched it long enough.
Clearly, these are areas that are now ice locked. It's getting cold.
And it's going to be interesting this weekend. Lake Erie, I think, is pretty much ice covered, and they're expecting like 60-mile-an-hour winds.
Oh, really?
So that's going to be interesting on the east end of Lake Erie.
Big sheets of ice.
Yeah.
And again, you can see the snow cover over much of Iowa as well, so it really shows up pretty well. And that's some high clouds beginning to stream in from the west parts of southern Minnesota. Let's step back again, and let's go west for a moment. We'll go to the west coast. And a couple things to note. It's this weather system that we see here over the southwestern part of the United States. be a nice cyclonic turn into the flow with lots of very small cumulus clouds in this region. Flagstaff, Arizona had its, I think its snowiest day ever, maybe snowiest February day ever, with close to 3 feet of snow in one event. That's just, just tremendous for them. So it's huge snowfall out in the western part of the United States. Parts of Los Angeles down to 600 or 800 feet were reporting snow, and there were snow-covered areas into some of the suburbs of Los Angeles with as this system went through yesterday. So a fairly potent system, and that's going to play a role in our weather later on this weekend. And it's been part of the stream of systems. We'll see the origins of this weather system actually on the superpeats. We can see actually traveled right down the west coast of the United States, giving them significant precipitation, and it's now located in the southwest United States. And there's yet another feature that's further upstream. We'll watch how that evolves as well. Over the Pacific, looks relatively quiet to my eye until you get to just southwest of the Aleutian Islands, where we have a developing cyclonic wave. You can see the cloud shield associated with it, but things seem to have quieted up a little bit in terms of the so-called atmospheric river type events. I'm not really well organized right now over the question over the Pacific. Maybe things are going to quiet down just a little bit in terms of significant precip events. Although we'll watch this as it heads southward.
This must be, was it Silver Lake, Colorado had the all-time 24-hour snowfall record, 76 inches or some ridiculous thing like that. I think it was in late March or early April of 1927. It makes me wonder if it wasn't one of these,
Really deep cutoffs.
Yeah, deep cutoff lows over northern Baja California. That just look at the training of the at least the high clouds over
Right.
western Colorado and Utah. It's just amazing.
Right. I believe Tucson's that's actually currently getting some moderate snow.
Yeah, they had 4 in the Catalina Mountains, right outside of town. So they had 4 already. It was still snowing this morning.
Right. It's a really potent weather system, and as we'll see in looking at some dynamic control cause analyses, really cold aloft and unstable, so that probably going to trigger some showers later on this afternoon. But ahead of this fairly deep system, it's drawing in lots of water vapor from relatively low latitudes. You can see these low clouds are streaming northward with time. And then as they ascend, as they cool, and you're seeing that cloud pattern continue to emerge ahead of that trough. But again, it's a little bit quieter than what we saw in the Pacific last week. Okay, let's come back to the U.S. and first of all look at some radar imagery. We're going to see some thunderstorms over the south central United States. And we'll also look at the lightning strikes in just a moment. But you can see these are some convective weather systems, thunderstorms here with lightning. Then it turns into more stratiform precipitation as you get into just north of Nashville. And we'll see that there is a weak boundary that shows the 850 millibars as well as relatively close to the surface right in through the southeastern United States. But again, if you think back to about 3 weeks ago, where the models were forecasting significant precip roughly oriented in this pattern, this has really maintained itself pretty well. And again, it's the periphery of this broad subtropical ridge that extends from the central Atlantic across the Caribbean into the Gulf of Mexico. And we're seeing also some thunderstorms here. Presume these are thunderstorms. These showers are moving into the Gulf of Mexico north. So we'll take a look at that. We saw the clouds that were moving into Minnesota, and further upstream of them is where we have some light precipitation falling. We guess most of this is perhaps frozen. It's relatively cold there. And here's some precipitation that's falling in the parts of Arizona where the radar is hitting some mountains and getting attenuated there. Okay, so that's let's look at the lightning strike map. See where we're actually getting lightning strikes from our network. Not our network, but the network we received. So here are the thunderstorms, those showers that were moving in from the Gulf of Mexico here, at least so far, haven't produced any lightning. It strikes really back over parts of northeastern Texas and northwestern Louisiana.
Yeah, so that
And a couple out here in Arizona as well.
bulk of that precipitation that's kind of in the lower Ohio River Valley is all stratiform. At least it's not convective, it's not lightning.
Yeah, broad stratiform precipitation, we'll see the flows. And consistent with that, and there's again a weak clinic zone with some, I would say, relatively frontogenesis along it. That's keeping that. Okay, so let's take a look now at our maps of sort of 500 millibars on the superpeats. And And the really interesting, I think, first, two conspicuous features on this map are going to be the broad ridge that shows up over the southeastern part of the United States. And of course, this very intense trough with temperatures at the core of it, 500 millibars, down to about minus 34, maybe even colder than that, maybe minus 36 at 500 millibars in south central California. When we look at the sort of temperature advections along, first of all, the temperature gradient along this, a very nice, well-developed upper front, I presume in this region. You can see just go right off the coast south of San Diego. And I guess some weak cold advection, which may be suggestive that this trough and the fold associated with the front could deepen just a little bit further with time. Another feature that's further upstream, catch this other upper wave that's located just over British Columbia. What I'd like to do is just step back to the loops and just trace this feature back in time. We have this succession of waves that have moved down in this northerly flow over California and kicked out to the western part of the United States. And so we go back to the beginning of the current time, and then we step backward. So this is today at 12Z. And we go back in time to see the history of this particular disturbance. Kind of gets hidden in here, but there it is, right here. This is it. For Alaska, and then maybe we'll just stop and go one more backward. And you can see preceding it was another fairly deep trough that was over the western United States that followed a very similar pattern. We can just trace this in the back as well. I believe this is the one that produced the snowfall last week in Seattle last weekend. So we've had this train of disturbances in the northerly flow off the west coast of the United States. They've come down through the southwest, sort of picked themselves out, produced our weather over us. So if we go forward in time, we can just in past week's weather with this. That first trough that kicked out, and another one here. This was on 2 days ago. That's going by. And then here's the current one that's taking shape just out over the southwestern part of the United States. And again, this really broad, kind of stuck ridge that's about off the southeast coast of the United States. Let's go up to 300 millibars. Actually, 250, please. Take a look at the structure of this. Yeah. Looking at this, we can see perhaps the merger of two jets right off the northeast coast of the United States. Can't recall which day it was. It was just about 2 or 3 days ago, maybe Tuesday, where we had, I guess, record-breaking winds over the Atlantic at jet level. I think it was
801 mile per hour ground speed.
Ground speed for an aircraft that was going across the United States from Los Angeles, I think, to London. They had recorded a ground speed of 801 miles an hour, which is just nuts. I think they probably arrived before they took off or something like that. But notwithstanding, I think it's partly the combination of really this strong, sort of very persistent ridge over the southeast United States and the relatively colder air that's been to the north that's kind of characteristic of this time of year anyway. But we can see today this, I presume this will be our subtropical jet. We can perhaps look at, is your jet diagnostic page still?
Yeah.
Right, so we can take a look at that. And then we can see that this is presumably a merger of a polar jet with a subtropical jet right just off the northeast coast of the United States. 176 knots is nothing to sneeze at for that. But you can see again the really strong jet maximum that still exists on the western side of this trough at this latitude. It's warmer here, so we're now above the dynamic tropopause in the lower stratosphere, with the temperature minus 44 at San Diego. And then if you go west of it, or east of it or west of it, you'll see colder temperatures. So we're in the lower stratosphere with this really impressive trough. Here's another, we saw evidence of it in the satellite imagery. Here's this next wave that's to the north. This one, as we'll see in the forecast, doesn't seem like it's going to dig as far south as this upper trough did. It's going to stay more in a higher latitude. Maybe signaling a slight change in our regime. Okay. Let's go to, actually, let's check out the jet diagnostic page that John has. I don't recall the link, but it should be on the AOS page.
Maybe this is subject to some of the problems with the data stream.
Yeah, we've been having issues with the conduit data stream lagging and we're losing data.
That's all southern hemisphere, so I'm going to go to the northern hemisphere.
Am I on the right page here now?
Yeah, that's the right one.
So let's go to the 5 a.m. one to the 6C. Just in case it's lagging, maybe it's in here now. And we want to get,
I would do that one is one. So that's just the ice attacks in the 100 form millibar layer, and there's no superpositions indicated. But if you go to another link, that's the subtropical jet in red and the polar jet in white, or maybe it's the other way around. Yeah, it's white subtropical jet. So they
not
get
quite,
close.
they get close, but they don't actually superpose.
And they get really close in the south.
You can see the two separate jets here. And I guess over much of the hemisphere, there's not much in the way of superposition. This isn't
Almost
really-
there, yeah.
Almost there, but we don't see the reds. It's right up there.
But a few days ago, when those walking moon schemes were, Andrew checked, it definitely was superposed.
Oh, is that right?
And it seems to have been one of his subtropical dominant cases
Oh,
where
yeah.
the subtropics came to the cold
Yeah.
jet itself.
Was this just over the Western Hemisphere, or was that, can you say something more globally about that?
I didn't look at, I don't know where his maps are, where I didn't look at this, but what I looked at briefly, it looked like there's a couplet that actually formed, like an anomaly couplet in the geopotential height that actually formed a really strong jet off of the west coast, and then they all propagated slowly to the east with time, and then probably just reinvigorated for some reason to superpose. But I don't know if it was superposed for that whole time, but it was definitely really, really strong over the west coast, and then the whole system sort of moved to the east together. So
It's really weird last Friday what we saw. It didn't look like a superposed event. It must have been later in the week.
Yeah, I don't know if you caught this, John, but in the Atlantic just a couple days ago, just one of those run-of-the-mill 936 cyclones.
Oh, yeah.
I texted you an image of that from the Ocean Projection
I
Center.
didn't see it, yeah.
It was really impressive satellite imagery. So it was really nice. That was a really nice event. But it's again, dime a dozen this time.
Yeah, that's why, we don't name them. We don't waste our time putting names.
Yeah, but they have to acknowledge that they're hurricane force winds associated with cyclone. They have to boost it up to make
Yeah,
it.
it's just a convention. It's just a convention.
Anyway, so let's go back to
Can
our.
I point out on the figure that the remarkable thing on there is this is a subtropical jet in the eastern hemisphere is almost continuous from Africa all the way into the Pacific. And looking at the Prague, when I'm looking at it, it actually becomes continuous all the way across southern North America, from Africa all the way across southern North America into the Atlantic. So it's like a wave number 0. It's just, I think, and most of the polar jet signatures go away by 8 days from now. So that it looks to me like it's the least wavy pattern I've ever seen.
Oh, you can measure that. I haven't thought about that. I can do that every day. Maybe I'm even doing it without knowing, but I'll check.
So we have to, we'll take a look at that in the forecast and certainly look at a hemispheric map later on. I would note that about 8 days from now, we'll see this in our look at the GFS, and this has been a persistent feature in the forecast, so it looks like it's beginning to lock in, is another significant cold air outbreak that it won't beat what we had just a few weeks ago when the schools were shut down, but it will get extremely cold with highs probably, possibly staying below 0 or in the single digits just a little over a week from now. So that's something we'll watch. And it's going to be associated with, again, a slight regime change where maybe the whole hemisphere, the jets were suppressed to the south, where we said with the subtropical jet.
Yeah, I would think that's the necessary ingredient at this time of year. You don't want to have high amplitude fluctuations in late February, early March and still get cold. No way. You need to have it isolated at the pole. It's the only way to leak cold air anymore.
And I don't know the persistence of this feature, this sort of blocking ridge-like feature east of Greenland, but I mean, is this a block or just a transient?
I think as maybe we would expect, we still don't have a polar night jet up there, and not night anymore. So I guess we're not going to reestablish one, but I think it has something to do with this problem that we're not seeing a lot of tropical plumes or any tropical plumes that are really making it up into the Arctic. Most of the tropical plumes I can see around the globe are in the southern hemisphere right now. There's hardly anything going on in the northern hemisphere, and that's why we're just so zonal everywhere with the subtropical jet.
Again, I don't know if
There's,
it's-
there's that little thing going on in the Atlantic.
And that might have been associated with that 936 cycle that rapidly deepened
Right.
roughly in this location about 3 days ago. It may have helped to trend.
There's something in the Atlantic, that's the only place, and that's in the break between this, where the subtropical jet spirals around the planet, and it's a little higher latitude when it gets back to Africa on the on Western Atlantic, or into the Atlantic west of Africa. But it's mostly just staying in the tropics. It's a different circulation than I can recall in a long time. Just seeing that big of a zonal subtropical jet without a lot of plume activity into the Arctic.
So if you remember to come back to this perspective, near the end, we'll look at sort of the medium range forecast to see how it looks. Let's go back to our super feeds that go down to 850 hectopascal. And we can see here, across the southeast United States, you can see, I mean, one, there is some barochronicity here, there is some turning to the wind, a bit of a trough right here, so there is a baroclinic zone with some vorticity. This is a front of 850, and there is some weak frontogenesis, so there's certainly deformation along this zone, which would be associated with some of the precipitation that we saw on the radar earlier this morning. And again, I keep pointing this out, but it's fascinating to me. It's a broad subtropical ridge out of the southwest Atlantic, with the southwest North Atlantic, with the broad easterlies across the Caribbean, and then turning to the southeast. That's really helped to loosen things up. One thing we didn't look at was the surface map, so let's go down from 850 to the surface.
Yeah, there was a comment online, I think it was when we were talking about the zonal wind, it says, will Typhoon Wutip, that's the name, change that?
That's possible. There was
It's
a,
not showing that in the procs. It's not showing that, but you would think it could.
we should, if we can go to a hemispheric view. I know your maps have those, and this was actually well forecast a week ago in the Pacific. Hemispheric view of the GFS. Currently, we can look at where that typhoon is. I think it shows up pretty well. Go to the analysis this morning. Let's go to 850 actually. There it is. This cyclone, but I guess the influence of this in terms of influencing the jet is probably going to be a function of how close it can get to begin interacting with the jet, or its outflow being interacting with the jet.
It might be responsible for strengthening the subtropical jet, not necessarily ridging it up to the pole.
Right, but just helping to have an outflow of very high theta at the tropopause that's going to get it back to around the south side of the already existing subtropical jet with strengthening. So from 850, again, develop. At 850, again, this is color coded with temperatures on it and geopotential height. Again, that is well, maximum in the southeastern part of the United States, and it's flow northward. Sort of a trough along the sun right here, which is where we have the precipitation occurring with that wind shift, which is a flow. And the cold air again locked very high latitude that you perhaps expect at this point. But we're going to see this reemerge over the northern part of the United States in just about a week or so. But yeah, this will be a feature we'll have to watch. I haven't seen anything in the forecast that suggests that's going to be a big player. One aspect, I'll take that back. One aspect is we'll see the forecast for next week is suggesting maybe some snowfall, a fairly significant weather event. But if you look at the last 2 or 3 cycles, the models have been flipping around, so it's not locked in. And maybe the source of that uncertainty is due to the evolution of this feature. That's not something I even consider tracing back to. But now go back to the surface map, and we'll begin looking at the forecast. And we'll first start off over us, 29 over 15. So that's just a nice winter day and relatively clear skies, at least in the analysis. If you go further to the south on the map, you can see where that stratiform precipitation is, light rain. This is Nashville right here, right? 48 over 44, light rain, 2.5 miles visibility. And then look at this, 82 over 66. Wow. I mean, that's summer. That's a nice summer day for us, probably we get to eat, but nice temperatures if you can get it. But dew points again along the Gulf Coast in the low to mid 70s to 79 to 73 in New Orleans, and then You can see it gets a little bit cooler, some of the rain over parts of Texas, and but there's a nice drop in temperature here from 70 to 55, just northeast of Houston, down to 59. So that's kind of not much of a wind shift. Really warm, high dew point there. It's pretty nice. Let's go to the southwestern part of the United States where they're getting some snow earlier. There was light snow. I'm sure if it's Tucson or not.
I think it is, because, the one to the northwest is Phoenix.
Right, so 33 over 32, light snow there, light rain in Phoenix, 42. And this is Flagstaff, 31 about 27, with lots of snow on the ground. Baseball. To our southwest, where we're seeing some light snow and even moderate snow over the Dakotas. This easterly flow is really ascending. You think it's flat out here in Kansas and Nebraska, but actually you are going a significant incline as you go from east to west, and so that southeasterly flow is slowly ascending, and there's some precipitation in a very deep upslope in that region. And I guess the last bit is just fairly obvious. Broad anticyclonic circulation, high pressure, anticyclone maximum sea level pressures here around 1,032 and a half, 1,033 are still in this region. So the high is just about centered over us. We probably suggest tonight we don't get much of the clouds. Nice light winds tonight will cool off a bit. The clouds are really encroaching. Okay, and the low dew points over us is something we'll also have to factor in for the forecast. So let's now go to the forecast. Let's go to the pivotal site, please. And we will start at, we'll look at the surface and we'll go to 0 to 9, so we'll go to 12 hours of the forecast. And so what that suggests for us by this evening, the anticyclone was over 1,033, will move to the east. Maximum sea level pressure will be now located east of us. Again, this region of barometricity to our south and the associated precipitation along that front just continues to persist in that region. Again, some of this is a mixture of vector precipitation and stratiform precipitation. It's forecast by the model. We can see in the thickness field where that upper trough was located, it's still slowly making its way eastward, but still producing a lot in the way of snow. We saw that sort of plume from northern Mexico into the Rocky Mountain region, and here's where the precipitation is falling just ahead of that upper trough.
The pressure gradient's odd, isn't it?
Yeah, it's cold
The
here.
low, I mean, that
Very-
low is so long and thin. What is that all about?
And there's a west-southwest flow, or south-southwwest flow across the Rockies, so I wonder if this is a hydrostatic reflection of that.
Yeah, part of it's lee side, part of it's synoptic, so it's kind of a nice combination maybe.
We have the lee side effect. We also have this upper trough impinging upon this
Well,
region.
why is all that pressure gradient in northern Colorado? What's forcing that up there?
Flow is changing direction. We'll look. Let's go.
I mean,
go
the
to
pressure
850
gradient is jammed in that one place up there, and,
right here.
yeah.
So let's look at 850 or maybe 700 hectopascal just to get a broad sense of it. But I think you have a broadly confluent flow ahead of the upper trough. Not as evident here, but we have just a weak westerly winds to the north, and I don't know how much this is contaminated by the mountains, but we have a lee trough that even shows up here at 700 hectopascal. This is all sort of a lee trough. 850, just for a second, let's go to that. Just hold there, just hold that right. Was that just hydrostatically, you're sort of limiting the extent
That'd be
of
my
the trough?
guess, yeah. If you're lowering the pressure everywhere in the plains, and you got a little bit of residual cold air in the northwestern part of the state, that probably enhances the pressure gradient.
It's just that there's not an Arctic system plunging down.
Yeah, there isn't anything obvious.
Push it
It's
south.
like a residual, weak, cold pool. But maybe it's just phased perfectly right to do that.
It might be a very shallow cold air that's dammed up against the Palmer Lake Divide in central Colorado and can't get across. Yeah.
I'm interested with the little feature here is not too much of a forecast like that.
Larry did.
I don't think that's actually a thing, is it?
No.
Okay. Something so you can chip in
Yeah, right.
and taste it. Okay, let's go to the surface. Oh, I already looked at the surface this time. The only other bit right here is, strong warm advection occurring to our southwest over parts of southwestern Iowa and north southeastern Nebraska. So localized, strong localized convection. Perhaps there might be some asset here, but the question is how moist is the air at this point. Let's look at the 3-hour accumulated precipitation ending at this time period. And not much in the way is actually occurring yet on down here, because you have to look this air pretty far up before you actually get some precipitation. Let's go back quick, please, and let's go to tomorrow morning. Actually, let's go to 16. Let's go to 18 hours in the forecast. And precipitation is just approaching us, but here we are. It's still dry. The high is really retreated or moved toward the east pretty rapidly. Light snow in Minnesota, some freezing precipitation to our south, and then just plain rain when you get into southern Iowa and further south.
Notice how that low in Colorado's moved up to the Colorado-New Mexico border.
Right.
That's getting, right there, that's starting to look like a real good situation for heavy snow in Denver.
Okay, so we'll check it out as this cyclone begins to develop. As Greg suggested, it's like a really good situation for some Denver. Let's look at the 500 millibar map. You'll also see that this is a really impressive trough. The changing curvature around it's really going to be pretty cool. Yeah. If you look at this, going from very strongly laconically curved to the downstream, I would say modest ridge right here, I would suggest probably at this level favorable divergence in the mid-troposphere in this region along the New Mexico and Colorado border at this time period. And with the surface cyclones also being in shape roughly in the same region, so this would be a favorable situation for it to be in deep down. Okay. Let's also just look at a sounding roughly at this location. One of the issues that's coming up for us forecast-wise is going to be the possibility of freezing precipitation as opposed to frozen. Okay, we're not getting, I don't think at this point we weren't expecting any precipitation, but you can see from this sounding, approximate sounding near Madison, the GFS is forecasting surface temperatures of around 24 degrees, dew point of 21 at the surface, but if you go up to about just around 900 millibars or so, expecting temperatures to be above freezing. So a pretty good layer of above freezing. So this is going to, any precipitation that's forming, falling in this region is perhaps, at least according to the algorithm, is going to be melting and then refreezing upon contact with the surface. So this is a setup perhaps for freezing rain.
There's a big dew point compression there though, in that very layer.
That
So
can
I'm
cool it
imagining-
up there.
Yeah, you can cool it
things
off.
off so you can actually get the wet ball that you're probably going to be somewhere in the, well, certainly below freezing for the wet ball.
Is that what that line is? Is that the wet bulb temperature probably?
That probably is.
So there still is an inversion. Okay, there still is. I don't know if it gets above freezing.
But yeah, so we're still, yeah, it looks like if we're at wet bulb, we're going to be below freezing. So if we're precipitating, yeah, it's warm here. That's their algorithm, but John's point is a really good one. That's why I mentioned the dry air earlier, but forgot it immediately after saying it, that's going to give us a possibility of at least starting off with frozen precipitation. Let's look at another model. Let's look at the NAN, also from 12Z. And it has a, yeah, still dry, relatively dry layer here. And if this is correctly the wet bulb, then we would still be, if we had precipitation occurring at this point, we would be very likely still frozen.
I don't know.
You don't think so?
That's so warm.
It is warm, but it's so dry. I mean,
Yeah,
I
it's
can't imagine
evaporating.
you're gonna get raindrops falling through that without evaporating.
Okay, this is still this is at 6Z, so it's still around midnight.
I mean, if it exaggerates how dry it is, then we're in trouble.
Right.
If it really is that dry, it's gonna cool off.
Well, it's not gonna be that dry once it starts raining.
We go forward 6 hours, I think. We just advance this.
It's 3 hours.
3 hours. You know, this layer is certainly moistened up. We still have this, also you see really strong veering with height of the wind, but we have this deep layer that's forecast by the model to be.
It looks like the models are forecasting Virga there, aren't they? Because
That was evaporating.
because you wouldn't have such a low dew point if there was actually raining.
Yeah, how could it sustain it for that long, right?
Now 12Z, and it's kind of the moistening is proceeding downward, but we still have this really thin layer right here.
No, they're even saying no precip at all
And,
in this
right.
one.
Yeah, I don't think it's.
Confusing. Yeah, it's a lot of
Go
things
ahead.
to think about.
The 15Z. This is an ammo, switch back,
Oh, there you
then
go.
saturated.
No,
And in this
no,
situation, yeah, there's no option for us to,
Yeah, that's
to,
bad.
yeah. If our surface temperature is freezing, we're gonna get freezing rain. We're saturated, it's precipitated. Let's look at the GFS.
That must have affected it. I mean, I don't think it's
Yeah,
Yeah.
it's not all.
Yeah, but yeah, we have to also remember that factor that there's an action.
Well, same for
Yeah, let's go back to this.
Precisely. This one says snow. That's 3131.
Right, but you can also see right here, there's no part of the column that's above freezing. This was just, this is valid just 3 hours before. So I think the comment that he made about, or this is probably being affected in.
Yeah, this is earlier than that though. This is 3 a.m.
The 3 a.m. Yeah, right. So we moisten up between those two time periods to get there. It's not just precipitating water vapor into the column and letting it moisten up. There is some transport. So that's one of the issues, is just when this precipitation is going to start, what form it's going to take. The models seem to suggest that we're going to be frozen or freezing precipitation by the time we get to 12Z in the morning. And we go ahead to 15Z in the mid-morning tomorrow, 9 o'clock. This is, again, the GFS still suggesting snow. And if we look at the NAM at the same time, let's just go forward. Fairly. Freezing rain here, and they have us decidedly above freezing. So this is going to be a challenge.
What about the other GFS?
This is the FD3, the newer model that's about to come in March to replace this all. Thinking.
Maybe it's not there.
There we go. It's in freezing rain, and it does have us actually above freezing here. So that little layer right there is above freezing. Really saturated freezing. One of the things, and again, we have to look at all the characteristics of the model, and I don't know much, I can't speak much to the FD3, but one of the issues I know it's been helpful in the eastern part of the United States, or typically, is that the NAM, the North American model, has a higher vertical resolution, and it's better able to trap these sort of cold layers near the surface than the GFS, maybe also true of the FD3. And so maybe leaning more toward the NAM in this situation might be a valuable thing to do.
In watching these models, I rarely see any time that the NAM beats the GFS, even with its resolution. To me, it's a useless model.
Good. So we'll see how this actually will ultimately see how this is verified. Let's just go ahead, go back to the GFS, more familiar model, and then let's go to 15Z as well. Oh, no, we're already there. Let's go to 18Z. 10 more hours. How long will this last? We'll look at some surface maps to see that we are still precipitating. This suggests that the rain continuing at least through noon tomorrow. And for the NAM, we'll finally go back to the forecast. Well, that goes back to snow. This is just bizarre. I don't believe that.
Yeah, it doesn't seem right, does it?
Even though there's a deeper layer of cold air there, I don't see how that we're going to or warmer air, rather. I don't see how we're going to get there.
How do you turn back into a crystal in the shallow layer of cold air?
Right, that's probably half a kilometer. Okay.
It's always something.
Yeah, always. All right, so let's close this out. One of the forecast challenges for this is the precip's going to come in. Let's go back to the surface map. All right, so it's 1,000 hectopascals at this time period. Let's go forward to tomorrow morning. Down to 995, it hasn't moved much. We're talking still just upstream of it. So this is really.
Boy, look at Denver.
They're probably going to be just on the edge of that snow, right?
I
I mean, again, if you look at.
No, I think that's in Denver. I mean,
Okay.
I think that's getting them. It might be at this point starting to pull out. But.
And for us, again, strong, warm thickness, just sort of thickness advection in the surface. And this is just before the precipitation is actually expected to arrive at GFS. It's just to our west.
But this is one of those situations where up at Fort Collins, they probably won't get much at all out of this. Because the northerly flow is going to downslope off that Cheyenne Ridge. But Denver, looks like this is the kind of storm that nails Denver.
We'll take a look at the forecast for Denver just to see what ultimately transpires there. But one of the things to note in this event that's coming up, we have this initial push of precipitation, which is large in this form of convection regime. It's not really directly associated with the cyclone back here in the Prairie View Upper Trough. We're going to have sort of two phases to this event that's coming up for the weekend. Let's go ahead to 36 hours.
It's like a pre.
like a Prius. It's pre-light or pre-ish.
Yeah.
Not really like a pre-ish.
You know, I heard up until this point this year that Seattle's had more snow than Denver. And Denver's just really behind.
Is that right? Yeah,
Yeah.
they have to be way behind. Seattle had their record February, I guess.
Although the Boulder areas, talking about there, they've actually had a pretty wet winter. I don't know, wet.
Wet with rain and stuff too,
Rain and snow,
which is
right.
ridiculous, but yeah.
Big snow for your hometown.
Yeah.
Big
Oh, yeah,
snow.
for Lincoln, yeah, that's, get you to dig out. But the other part of this is northwest of the cyclone, the GFS at least is forecasting fairly heavy amounts of precipitation over this time period, this over the 3-hour time period, and really strong winds. And so that, let's look at the winds actually. It's a situation where they could, 25 knots sustained, maybe they're going to get gusts that'll be higher than that for those blizzard warnings, but then, that might not be an unanticipated aspect of the storm. At least for some regions getting the wind criteria, the snowfall rate criteria for some portion of the plains that actually be under blizzard warnings tomorrow. We're still in this nice warm advection pattern, so we're going to be warming up after the precipitation ends, going back to the preset now. The light precipitation may be going to plain rain by the time we get to tomorrow evening. And then this is an interesting part of the event. We go ahead to 6Z. This has been consistent in the model, although we've done to speed it up. We get this second low that kind of jumps out ahead near, I guess it's closer to the triple point where we have the cold and warm fronts meeting, but this low here begins to fill, but everything goes toward the cyclone that's over Lake Michigan at this point. What's really interesting is if we go one map time beyond this, I think if we go 3 hours ahead, you'll see this trough begins to fill and the winds shift to the north and we turn over to snow and actually dry down a little bit. That's most of the precipitation will shift east. In some of the forecasts earlier this week, they suggested, it was a mild liquid precipitation and all of a sudden a burst of heavy snow once this trough began to fill and move out. This looks like more just a northerly flow with most of the snow staying in the northern part of our state. Go to 48 hours, so in the morning on Sunday, lots of snow in the northern third of our state, and we're just, if you believe the model explicitly, just dry and extremely windy during that period.
So we can go outside and open our coats and the window blows along over the ice.
Yeah, no, right. Well, the wind might, hopefully it'll dry things up enough that we don't, well, if you look at the surface temperatures, I don't think we've dropped off a lot by 12 days. We're still just about freezing or something. Really, the column above us is really shown off, but the surface we're still hanging around freezing. And you can see lurking to the north, these temperatures well below zero. Let's quickly step forward beyond this time period. Just watch the evolution of that cycle. When it deepens a little bit more, that's more staying power with it as it intensifies. We stay windy on Monday. Monday afternoon, things begin to subside a little bit. And we have this baroclinic zone that's now trapped over us. Notice our southeast ridge is suppressed out into the Atlantic at this point, so it's going to dry for much of the continent. Let's just quickly go ahead in 24-hour chunks. More light snow on Tuesday. John's going to be happy about that, fortunately. And then, I'm happy you're happy, John. I really am. And then here's more cold advection. The weak wave goes by, and I'm really going to just quickly go through this because I want to get to the sort of thing. This is next Thursday. Not much going on. It's going to quiet a week from today.
Friday, here comes it.
Friday, here comes another event. And we'll go 192. Maybe a little bit too far ahead. Yeah, John's definitely going to want to see the 180.
Yeah, already have.
Look at
We're
that.
doing a 180 here.
Already.
Yep, look at that. That's awesome.
Wow.
So that could be
That could be
next Friday.
really exciting next Friday.
If this track verifies, this would be a nice track.
Mhm.
That's the track.
It is, that's right, that's the track. We haven't even had that yet this year with all this snow.
Yeah, let's go have one more quick. Something to watch.
Secondary off the Carolina coast. I don't know
I
if
think it's
that's
a separate thing.
It's
Yeah,
too far away.
that's two separate. Yeah, that's two separate. 192, and we're winding down with this one. But the thing that, okay, I'll take the snow, but I don't want this. Look, 4 and 6 thicknesses that are just parked them up.
Look at that wind.
Yeah,
It's just howling as this goes by. Let's go ahead to
March 1st,
204.
in like a lion this year, looks like.
But you're roaring.
504.
And then the 216. This is really cold. This is really cold there. If you like the fresh snow cover, strong winds, let's look at our temperatures.
Oh, yeah.
It's,
It's at 12Z.
It's not
Guess
wind
with the
chill.
sun angle, it's
That's
probably, what's that?
That's actual temperature.
Yeah,
Yeah.
that's not wind chill.
We don't do
If you go ahead, just 6 hours, 18Z, we're just trying to get above freezing, above zero at this point.
it. It's hard to stay below 0 o'clock if it's sunny. How do you do it?
And by 0Z, we're probably tumbling back.
This is how you do it.
Yeah, this is the only way to do it. You need a first snow and
Right.
minus 20 to start the day.
And just to, we're gonna take a look at the hemispheric view in a second, but let's just go to the end of this period just for something that's hopefully a little bit more pleasing. It's warmer.
Oh, yeah.
Much snowstorm.
More snow. Two weekends in a row. It's Friday next week and then Sunday the week after.
Can we, see what the snow totals are for this weekend?
This weekend, okay, yeah, we can do that. So for the weekend one, let's go back to the surface map. Let's go to 60 hours. I
This
think
selection
we should be
Sunday
done
too.
by then. And then let's go back to 54 hours. Sorry, I just want to get this right. When it's just about over 54 feet. We don't want to just get to the end of, roughly the end of the event. Yeah. It'd be very little, I think, for us. Let's go to, assuming 10 to 1, 24-hour, our total accumulation is nothing that happened before that.
Nothing.
Yeah, there's that little finger of heavy snow that the model forecast earlier in the week. That's all shifted to the north, so we're gonna get pretty much nothing from this.
We'll try the other GFS.
Okay, the FD3, I guess it would be. We should begin looking at this, very similar, just about nothing. I'm going to go ahead to next week. I think this may not be soon enough, I'm going to go further than that. Not the total, let's go 24 hours. 192. What's it, Saturday? Okay, there's a storm, but it's not really present. The GFS, on the other hand.
Oh, yeah. 6 to 8, 6 to
or
10.
something like that. Don't believe it. But I'm going to see something that's really believable. Let's go to the CFS, 0Z. And this is post-spring break. Let's just jump to surface map. Again, I like doing this because I'm always curious about just what's the surface. First, we can see some fairly deep snow cover over us. And really,
Yeah.
we're still dealing with cyclones having a track like this, optimal track. This is, again, cartoonish because it's way out in the future. Probably build one model run back or something like that, the whole thing disappears. Or anything that looks like it. Right. Yeah. Fortunately, we'll still listen to someone later. But the bottom line is we stay cold. Just verify that, and then we'll come back. I keep promising to come back. Let's go to home here and then look at the CPC forecast for the next 6 to 10 days, as well as 8 to 14. Again, the blueness just indicates the probability, not how much colder than normal it's going to be. But we're right in the heart of just staying cold next 2
This
weeks.
is typical of sudden stratospheric warming year. The winter just drags out.
And we had no winter in December and the first half of January. Let's not forget that. If we had, we'd really have a reason to complain.
Right, but I think we have a reason to complain right now.
We do. We're getting back to a reason to complain now.
And then finally, we'll go to models, and then we'll go to the, how we resume this continental. And let's look at which one, the Northern Hemisphere. And we'll go to, what do we have for the Northern Hemisphere? What's the GFS? Here, what GFS? We'll look at that. But I wanted to, let's go to the upper air. Maybe we'll see something for the 15 now. Looking for that tropical cyclone. So you can see, maybe we have to go to your maps too. This is a show it. Although we can, let's flip through this. Let's go to when the cold air comes in. It was further off the map than yours actually were. And what do you benefit? Go to the end of the weekend. And then just let's watch the emergence of this cold air. We're probably going to go to 168 hours a week from today. We're supposed to be, that storm is just beginning. Yeah. And then just maybe 12 hours up. Right, those are zeros forecast. Which is one thing to note, that we're getting something different in the forecast. But here's that cyclone approaching next Friday. We'll go ahead. Intensifying, nice track, giving us the snow. We like snow. Not many do. 204 hours. Here's that really cold air just breaking off into our area.
nice seclusion, that thing that ends up over Greenland too at the prior time. It's really warmer than anything around it for a while when it's migrating towards the tip of
This one?
Yeah. Go to the time finder.
Look at this one.
Yeah, it's another nice.
Looks like
See,
Alaska's
look at that.
getting
Look
pretty
at how that
warm
area
there,
is
doesn't it?
really warm compared to where it came from.
See how warm Alaska's getting in this?
Yeah.
I mean, the poles are warming up on this whole thing. I think it looks like the polar air is just sliding off.
So we've lost our, maybe we lost our source of cold air and then we go to the end of the period. Take a look at that.
It's a
Kind of
resurgence.
reemergence, yeah.
Yeah. At this
Yeah,
level.
it's down to that. Yeah.
That's the persistence of our winter. And lastly, just if you go to your maps for just a second, I want to see the question that we had about the typhoon. Do we see any evidence of it interacting with the westerlies? That'll be it. So as that's coming up, just to recap everything, precipitation tomorrow morning, probably snow and freezing rain, a mixture of those. Plain rain by early afternoon. That ends by the late afternoon. And then we have a break, 8:50, just over. That's awesome. Here's the typhoon. We can scroll up just a little bit. Yeah, what's the most impressive feature on this map, John? Just while we have it up there.
I think that really cold pool over the archipelago poised
Yeah.
to descend over central North America is pretty intense.
Okay, you can say that, but the real answer is this feature out there. So that looks like it just so far we're.
Yeah, we can,
It's not moving.
and it looks like it hits I'm just making this guess based on what the 50 temperature gradient looks like at that latitude,
Right.
longitude. It's a flabby part of the jet, so it's not the right spot to hook
Have any impact,
on. Have
or have a direct impact. at least.
Right.
Well, it almost looks like it has to do with that thing going on in the North Pacific. See how that's coming
This
around?
one?
Yeah. At the
Let's-
end, I don't know.
Let's go to 300. We'll jet during that same time.
So you can still see it. And there's nothing there in the jet, that's the problem, maybe. A really flabby part of the jet.
Yeah. Yeah.
Actually, look at this. I mean, watch this area right here. I don't know, there's noise when it gets over there.
Well, here's an interesting question.
Yeah.
I noticed on the very first slide you put up that our snowfall total for the year is now up to normal for the whole year.
Right. Above now.
So, well,
We're up
Yeah,
to, yeah.
right.
for the whole year, yeah. So the question is, how much snow do we have on this date in the 100-inch year?
Oh, I think we were,
We can bring this up, right? We should be
I
able to.
think we could.
probably we could, yeah, I think we were probably over 90, because I remember we struggled to get over the 100-inch threshold
Ah,
in late February. I think we were already at 90. That was 7, 8, was it?
Was that one that 14? It was.
Next one. 14, 15?
No, that's
No, it
the
was
cold
there.
year. The snow year was 8, 9, or 7, 8. I forget which one. Yeah,
there
that's
it is.
so on
We
this
were-
day we were over 90.
We were over 90.
And we struggled.
Oh,
We
my
stumbled like a drunk soldier to this finish line on this one. But we finally made it.
With the help of the weather service.
Well, right. So one year I didn't complain about their snow totals.
We don't have to complain about the snowfall. That's a sobering thing to realize. We could have had.
That's a
So
good
I'll take this. I'll take it.
Look at that steady climb from December 1st all the way to March 5th.
Yeah.
That was an incredible year.
I picked that year to be away.
Yeah, you weren't here. I'm so sorry for you.
No. Anyway, thanks very much, Pete, and everyone here for participating.
Thank you, Michael.
Yeah, thanks.
Look at that storm, John. That's the storm I was wondering about.
Yeah.
You can see the,
There's a second one that comes in this cold air outflow off of North America that's really impressive too. It's not as good as that one. Yeah, that's
all right,
great.
I should say look at that. It's kind of normal.
Yeah, that's right. It's very
We
impressive.
caught him in a moment of weakness.
Yeah.
Impressively normal.
Yeah. What did they say about Bohemian Rhapsody when it first came out? Perfectly adequate. That was the criticism. Perfectly adequate. All right. All right, thanks. That was great. Thanks for, yeah. Thanks for doing the whole thing today too. I didn't have to